Welcome to Lesson 6. In this lesson I would like to introduce the concept of machine blocks. While Analyzer manufacturing takes care of machining of parts that touch or intersect, sometimes you need special machining to be done, mostly for hardware. So let's draw a couple of panels first. Let's make it 18mm thick. Let's say it's a situation with the bottom and an end. Now let's set the part properties for that. Our first part is our bottom. Let's just use MDF as a material. And we make a new assembly. Call it test or 1. And let's just for simplicity do a screw construction type. We want to use that for our next part, so we set next. And here it's going to be an end. Let's do MDF again. And we already have our assembly here. So basically what that does when it runs through Analyzer manufacturing, it just drills screw holes into the bottom in this case. You see we got those screw holes there. Now let's say we want to drill a 5mm hole into 100 by 100mm from that corner. So we use machine blocks for this. So I would change the layer here. I have already a layer made called machine block. So let's quickly draw a couple of construction lines here. Now what we need to do is we have to draw a box here. We want to drill a 5 by 5mm hole. So what we do is we draw a box, 5 by 5mm, footprint, and we want to drill it 12mm deep into the board, so 12mm. Now it's not quite in the right position. What I normally do is I draw a diagonal line across. And then I move it into the right spot. Use the midpoint. And I move it to our position. We don't need those lines anymore now. We can delete them. They're just construction lines. So what we need to do in the part properties, we select that machine block here. There's already a setup here, so you can just press machine block, so it'll name the part name as a machine block and also the material, the part material. Now the different types of machine block, the most common one is a hole. So you press hole here, it'll write hole into the part type. Now what we need to do is we have to select the assembly, so it knows to which part it belongs. We save that, and once you run it through Analyzer manufacturing, this will show a hole that's a 5mm hole that's 12mm deep. As you can see, when you click at it, it's through a 12mm deep hole that's 5mm in diameter. In Analyzer Manufacturing, we have a script setup questionnaire where you can specify which type drills can be used for a machine block with a part type hole. So you can open up the script setup questionnaire. In General Settings, you have a list of available drills for DXF holes. So in this case, all those ones, 3, 5, 8, 10, 20, 35 and 25mm, they're available to use as a machine block. It's typically the drill bits you have in your drill bank on your CNC machine. So if you have different holes, you may have to change this to your company specific settings. Now on our panel we can test some more diameter holes. So you simply copy them across. Let's say you want to have them 50mm apart in that direction. So if you want an 8mm hole, I usually properties, it's quite easy to change, so you change this to 8, down to 8. The depth is still the same, we leave it at that. This one, I can do a 25mm hole. And this one can be your hinge hole. So now if we run it through Analyzer Manufacturing, we can see all those holes being drilled at the specified locations. So it's your 5, your 8, your 35mm hole, 12mm deep, exactly as drawn with our machine block. Now, if you want to drill a 40mm hole, there is no specified drill bit for this. We have another type of machine block that we can use for this. So let's copy this across. Let's say this is our 40mm, 40 by 40mm machine block. Now what we have to do, we have to change the part properties. And we want the router to cut this out instead of the drills. So we have to change this to a C pocket, which is a circular pocket. That's all we need to do. And now if we run it through Analyzer Manufacturing again, you'll see what it does. You see now, it's using the router to make a circular pocket, 40 by 12mm. When you click at the tool path, you can see it's a router here, route instructions. So the depth is 12mm. It tends to use the largest possible router bit, so to minimize the amount of work that it has to be done. Again, we can open the questionnaire. And here, if we look at the trenching router tool settings, we can see the tools that Analyzer Manufacturer is using for doing pockets and general trenching routes. There's a 3mm setup, a 6 and a 12. So it's used the 12mm for our 40mm circular pocket, just because this is the largest one. So if you have larger router bits, it's probably a good idea to specify them here, because if you have bigger pockets, it'll do them more efficiently. Now let's explore a few other type of machine blocks. We want to copy a few of them across again. We don't need to redraw them. Once they're drawn, you can just modify them. Let's copy them 100mm to the right. Now let's do a rectangular pocket. Click at it. We want that pocket 100mm long and 50mm wide. Now it's obviously not a circular pocket anymore, or a hole, so we can change this to just an ordinary pocket. Again, we run it through Analyzer Manufacturing. Now this one is a pocket now, 100 by 50 by 12, and you can see there are the settings here. Double click at the line. Again, it's using the 12mm cutter. It does a rectangular pocket, 12mm deep. In Analyzer Manufacturing, we have the following type of machine blocks that we can do. Those have to be specified in the part type of the machine block. So there's this hole, as we've seen that already. We've seen pocket, we have pocket. There's also a rebate that we can do, and the groove. And all of them you can specify through at the end, which means it will route right through the board. So the depth that you specify there, that's not relevant anymore, so it'll go all the way through the board. So if you have a 12mm deep pocket and you specify them as hole through, it'll go all the way through. There's also a special one, a slat wall. If you're a shop fitter, you can specify slat wall routing. So let's have a look at the groove and the rebate. Let's do the groove first. Copy this machine block across. Now maybe you make it a bit longer, 200mm long. And now if you do a groove, we can specify the router it wants to use. So if you want to do a 6mm groove, we specify this as 6. But that router has to be existing in your questionnaire setup. What we need to do here is change part properties again. All we need to change is the part type here. So we call this a groove. And again, this one is 12mm in height or deep from the surface. So if you specify this as a groove through, it'll go all the way through your board. So it'll go through down 18mm deep. Let's check it out in Analyzer Manufacturing. So as you can see, it's done now a single groove. Double click on the router path. It's using depth of 12mm. At this time it's using a 6mm tool because we've drawn the groove 6mm wide. Now let's have a look what the rebate can do. Let's say this. Let's say we want to make a cutout, a rectangular cutout in this bottom, and then have a rebate around it. So we can specify the cutout 200 long, and we make it 50mm wide. Now this can be our cutout. This is like a two-step process, so we can draw the cutout first, can use the rebate through, and we can use the rebate to actually draw the rebate to cut around. So what we do is part properties, we call it rebate. Through. And keep in mind we don't really have to do the depth there. The through part specifies that it goes all the way through the board. So what I would do here is make a copy of this block, this machine block. I'll cut again on just a single click, so we have one specify. And we want to have a 10mm rebate around this cutout. We make this 20mm wider, so 220. And the width would be 70mm. Now again here we change our part properties. Instead of rebate through, we just call it rebate. Basically this one here is the cutout, goes all the way through, and that one will do the rebate. Now for demonstration purposes, I'll quickly change the part properties of the bottom. I'm going to give it an S property here. This is just to show the rebate through machine block, how it goes all the way through. If it's set up for a pod and rail machine, it probably stops short. Depending on your setup, it may stop short 2mm or 1 or 2mm above the bottom surface. While on an ester, it actually cuts all the way through. So when we run it through Analyzer Manufacturing, it's gone through the board by 0.2mm, being a nesting machine, 12mm diameter tool, and this one just goes 12mm deep. This is probably a good idea to see how it physically works in Analyzer CAD. So let's quickly export this. We specify a job and the work order number. We run the geometry script again, just to be safe, and now we run the translate script. Now let's start Analyzer CAD. We import. Here's our job. It's our work order. And it's the nested 18mm MDF that we want to have a look at. So that's our tester 1 bottom. We select the point where we want to import our CAM. So what it's done now, you've seen the rebate through, goes all the way through now. You should go down to -2, so it cuts a bit into the wasteboard. And this one is 12mm from the top, so but has, since an 18mm board, it has an elevation of 6. This is our groove. Our groove has a tool that does it in two runs. As you can see, there's 2 tool paths for it, and this is our pocket, 12mm deep, and they are our drills. and the 40mm one is a rounded C pocket, a circular pocket. These ones are the drills from our touch type end panel. They've been done automatically, we don't need machine blocks for that. To make a rebated cutout, you don't necessarily need the rebate through machine block. So we want to do a cutout here. We can draw this. Just specify the corner points here. Now we can do either a press pull down or a subtraction. So this one gives you a cutout here. It's quite a quick way to do a cutout. So that's an actual physical 3D cutout. It has done that. So Analyzer will realize that and will make an internal cut for that. So there's nothing you have to do there with doing anything with machine blocks or so. To draw a rebate around this cutout, you typically draw a machine block. Let's quickly change the layer to machine block again. I would just draw the box the same it is. That's the quickest way as it is. And then modify it with your properties here. The height, I would change, let's say if it's 10mm deep, you can put that to 10. If it's a 10mm rebate, you add the 20mm to it. So it's 220 and 120 at 10mm. So now the machine block is drawn around the cutout. All you need to do, change the part properties. So we change that to machine block again. We call it rebate. And we have to select the assembly. Always don't forget to select the assembly because that links the machine block to the part. And basically the same thing is if you have, you don't really need the drill through or the C pocket through or so. You can basically just draw a circle and cut it all the way through the board, and the Analyzer will do the rest of it. All you basically have to do is draw a cylinder. Say 43mm. In radius, that's 86. Just pull it out of the board. Or you can do one that matches a drill. We have a 35mm drill there, so it's a 17.5 radius. Pull it out, and now we can make a subtraction. This is our board. Press enter, select subtracted parts, and here are our holes. Now let's export this to Analyzer Manufacturing. See what it's done now. This one, it routes it. It's using a 10mm diameter tool, and it's running it all the way through. That's your 86mm hole. Now this one here, it's actually matching a drill. So Analyzer is smart enough to change that to a drill because it's the quicker way of drilling the hole. Rather than routing it out, it has used a 35mm drill bit to make that hole. Now let's see what happens when we export it to CAM. So therefore we specify job properties, job number and work order number. We run the geometry script again and the translator script. Switch over to Analyzer CAD. Now we clear all the parts that we selected beforehand and we get new parts now here. We're just interested in the nesting part here. There's a new part processed here. So this is our internal cut here. It's basically the same than the rebate through, but it's a bit more visible and it's quicker to do. So I would, wherever you can, use subtracted parts to do route through. This one has been chosen a drill. There's a specification in Analyzer Manufacturing that if your hole is smaller than 100 millimeter, even if it's an internal cut, it will make a pocket. Your CNC machine usually ends up with a small bit when it does just a cutout, and that gets sucked up to your dust extraction, which is not very desirable. So what you can adjust is in questionnaire if you want to have it from which diameter on you want to have it pocketed or just cut out. In the next lesson I want to show you how we can use machine blocks with AutoCAD blocks. You can attach them and make very useful blocks, especially for hardware. You can do all the drilling on a handle, for instance, and you can just import the block and place them where you want it. So that's all for this lesson, and I'll see you in lesson number 7.